Structural engineering principles workshop based on looking at this beam calculation, getting us ready for doing the shear force diagrams, bending moment diagram across a beam. So you've got to be able to basically take any point along a beam and work out what the shear force and the bending moment is at that point. Okay, so in order to do this, we need a couple of things. First of all, we need these diagrams. Okay, we need to identify what we're going to calculate visually, and that helps us work out the positive and negative shear, the positive bend and negative bending. So what is actually happening at that point? Is it pushing and pulling to left and right, that in a positive way, which means to the left it's pushing up and to the right it's pushing down, or is it in a negative shear where to the left the forces are pushing down and pulling up on the left and pulling up on the right? So those pictures really help. So X is in the middle of this beam, but X can be at any point. You follow the same process. So what you try and do is you say, well, actually, if I'm doing positive or negative shear, these are my options, right? I've just got to make sure I apply. If anything's going upwards to the left and I'm in positive shear and it's up, a force is going upward to the left, I need to make sure I make that positive, yeah? So that means that anything pushing down is negative. So with positive shear as well, anything on the right hand side of my X that's pushing down, that needs to be a positive value. And anything that's pushing up to the right hand side of my X needs to be a negative if I'm using this positive shear equation. So let's have a go. Right, positive shear, here we go. So what I'm trying to say there is all of my upward forces are positive and all my downward forces are negative on the left hand side of my X. I'll put an equal sign where my X is. Okay, so the equal sign represents the X, that's the point that I'm taking it from. And then I look to the right, and anything to the right of that that's downwards is positive and anything upwards is negative. As long as I apply those principles, I should be all right. So let's have a go. So to the left, I've got 44 pushing up, which I've put as positive because I'm doing positive shear, okay, and anything pushing down, which is the 50, is negative. There you go, end up with minus 6 kilonewtons. So then I move over to the right hand side, and all my downwards forces are positive, which is my 30 and my 40, and all my upwards forces are negative. So that's my 76. Okay, and you end up with the same value. This means my calculation is correct. What that also means, though, is I've not got a positive shear. So when you're talking about what's happening with that beam, it's not the case that 6 kilonewtons is pushing up on the left and pulling down on the right. It's actually the opposite. Because my answer was a negative, that's telling me that actually it is 6 kilonewtons. 6 kilonewtons is the shear force being applied, but it's in the opposite direction. So I've got it the wrong way around. So then if you have a go at the negative shear, then have a go, right? All you're doing there is looking at the picture of negative shear, and you're saying anything to the left that's pushing down is a plus and anything pushing up is a minus. Anything to the right that's pushing up is a plus and pushing down is a minus. That's all you do. And as you can see here, we come up with the same value, the 6 kilonewtons, which is negative shear, confirming negative shear. So I've just done two totally separate calculations using either the positive shear or the negative shear idea. And all you're doing is just saying, well, if it's in balance, your upward forces equal, so everything to the left of the X equals everything to the right, because otherwise it would be, yeah, it wouldn't be in sync. So it's in equilibrium. So that's perfect. Okay, so then I do the same, exactly the same with the bending. So positive bending, negative bending, positive bending. What I'm trying to say here is I look at the picture. So the picture's showing me positive bending. If I imagine my X is in the middle of that beam, if on the left hand side it's trying to make it move upwards, so anything moving upwards is turning it in a clockwise direction, that is always going to be positive. Therefore, if anything to the left is pushing down, that's a negative. okay? And then I look to the right and I say, well, it's the same. It should be the same because it's in equilibrium. So if I've got positive bending happening in my beam, if I look to the right, anything pushing up and making it go anti-clockwise direction would be a plus, and anything going in downwards, and that would be a clockwise direction. If I'm looking to the right, that would be minus. And then I apply the same thing. But don't forget, when you're talking about bending, you're talking about momentum. So it's a bit more than just the force. You've got to times the force by the distance, because the further away you get, the more momentum you have. Think about spanners and shears and that. If you've got an anchor that's further away and you're applying the same force, it means that the momentum is higher. So moments, you've got to remember that with bending, okay? So clockwise is plus, anti-clockwise is minus. So the 44 kilonewton is 2 meters away, so I times 44 by 2. And because it's pushing upwards, and if you look at my positive bending picture, pushing upwards means it's a plus. So that's perfect. The 50 is pushing downwards. It's only 1 meter away, so I'm timesing 50 by 1. And because it's pushing downwards, it's negative. Okay, so that's it, done. And I do the same on the right hand side. Okay, my 30 and my 40, both of them are pushing downwards on the right, which is not my positive bending, is it? It's the opposite of what my positive bending is, so then minus. And then my 76 is pushing up on the right, which is perfect, that's a plus. Okay, but my distance for 76 kilonewtons, it should say, not key. It just says K, it should say kilonewtons, is 3 meters away, so 76 times 3. And as you can see, it comes up with a value, the same value either side, because it's in equilibrium. If you were finding different values, you're doing something wrong, so you need to readdress it and have a look. So that tells me it's a positive result, which means that confirms my positive bending. This is the picture that's actually happening with this beam, okay? If it's negative, it would be the other way around. So what I do is I confirm it. I'll do my negative bending one, and I'll say, do you know what? I'm going to use that picture instead. So anything pushing down to the left and anything pushing down to the right, they're positive values, okay? And anything pushing up to the left and up to the right are negative values. And if I apply those, I'll end up with a negative 38 kilonewton meter, which is the same value. Notice how they're the same. So it's perfect. So what this is telling me is that for this beam at that point X, I have I have negative shear. So if you look at the negative shear picture, that's what's happening. To the right, it's pushing up, to the left, it's pushing down by 6 kilonewtons. Then when I look at my bending moments, I look at the bending, positive bending and negative bending, it's confirming positive bending. So what's happening is to the left and the right of the X, it's pushing them up. It's the forces are pushing them up the way. Okay, so it's sagging in the middle. It's sagging where the X is. I hope that makes sense. Please watch videos, do whatever you need to get your head around this, and I'll see you in class. All right, cheers, bye.